You all know this sound. This is the sound of the human heartbeat. But how many of you actually know what the human brain sounds like? You've all seen what the brain looks like. But how many of you know what the brain actually sounds like? We here at Infant, the Irish Centre for Fetal and Neonatal Research, have developed a way to listen to the brain. And here it is. I bet that's not what you thought it would sound like. It's amazing, isn't it? No artificial sounds were added, and that is from a preterm baby's brain. But before I go any further, how do I look here today? I know, the things I have to do. Seriously though, this cap is an EEG cap. It contains numerous sensors that allow us to monitor the brain's activity in real time. And you might ask, why is this important? Well, I'll go into that in a few moments. But in a sense, it's like looking into a window into the brain. Beautiful, isn't she? She is one of 78,000 babies born here annually in the country of Ireland. Of these, 4,800 approximately are born prematurely. Or to look at it another way, every 116 minutes, a preterm baby is born. To give you some context, in Ireland, pregnancy and birth are usually low risk. However, 1 in 50 babies may need some form of medical intervention. And for that reason, we have neonatal cots like the one we have here. To give you some more context, a full-term pregnancy is usually 40 weeks on average, and the baby weighs approximately 4,000 grams. Whereas with a preterm baby, it is defined as a baby less than 37 weeks. And they usually weigh about 400 grams. So if you think about that, that's staggering. It's like 10 times less than what a full-term baby weighs. Or another way of looking at it is the smallest of the smallest babies may only weigh just as heavy as a bottle of water. Or another way to look at it is these babies are so small that if you took off your ring, their actual whole arm could fit through it. So they're that small. So how can we give these little ones the best start in life? So to do that, some of the smallest people on the planet begin their journey in an incubator like this one here. And this incubator typically has a blue light. And with this blue light, it helps with jaundice, and this is also temperature regulated. We also monitor the baby's heart rate and breathing. But what we do here at Infant is we also monitor the baby's brain waves. And we do that using this type of an EEG cap, like the one you can see here. So it contains sensors, and we can monitor the brain waves. But some of you might be wondering, how have I been left holding this baby? Or how have I come to this career path in some ways? So my fascination began when I was a 15-year-old with technology. And a few of my classmates and I came together, and we decided we'd try our hand at business. And to be honest, we didn't fare too badly. We came second in Europe. And some of you might ask, well, what did we do? Well, apart from dressing up as men in black at the time, I know this was all the rage back then, but we actually set up a web development company. And I know some of you mightn't think that's very cutting edge right now, because 8-year-olds today can write complex code. But at the time, we were also looking into a thing called Wireless Application Protocol, or WAP. And what WAP is, it allows you to send internet content from the internet to your smartphone or to your tablet like we all have here today. And although WAP has been outdated now, it was the kind of beginning or the platforms for such technology. So then that got me thinking in terms of how could I apply this to health? That led me to complete a PhD in neuroscience and to investigate people having difficulties with brain disorders and trying to figure out how can technology solve these complex brain disorders. And just to give you an illustration of what fascinates me about the brain is that this is the brain here, and the brain can be divided into two parts. There's the first part is this part down here, the lower structures in some ways, is a primitive cortex. And what the primitive cortex does, it allows us, like animals, it controls our breathing and our autonomic functions in some ways. Whereas this part here is the cortex. And this cortex is what separates us from animals and makes us the most evolved species on the planet in terms of it allows us to think in real time, but also what's fascinating is it allows us to understand things. And that can be very powerful, and I'll give you an example now. So this here is the latest artwork that my sister sent me. I got this message on WhatsApp recently, and she said, "What do you think of it? What do you think of it?" It could be anything, couldn't it? So what came to my mind straight away was, I thought maybe this is Purkinje fibers. And Purkinje fibers are the internal workings of the heart in some ways. And that is what my brain deduced because of a background in medicine and neuroscience. So this is what I saw. So I wrote back to Avril saying, "Av, you should call this Purkinje fibers." And sadly, she wrote back to me saying, "This is actually a close-up of rust off a tractor that we have at home." So yeah, needless to say, I don't know much about abstract art. But what actually struck me was, how is it that my brain could connect one thing to another? Or how is it that, if you think about it, different perspectives can impose different perceptions on things? And that is the key to understanding how innovation can come about. So we here at Infant have come up with a way of looking at things in different ways, bringing together doctors, nurses, engineers, scientists all together and coming up with an innovative technology to help monitor the brains of preterm babies. And this EEG technology we use regularly in the neonatal unit. So some of you might ask, well, why is this important? Well, when an adult is having a seizure, you will actually physically see it happening. It's right in front of your eyes. You will know, you all know. Whereas when a preterm baby like this one over here, they can be nice and quiet and still, and we don't know whether they're having a seizure. So the only way that we can detect that they are having a seizure is by using this EEG cap. What we look at is a waveform like this. You can all tell me what's going on there, can't you? It's nice and simple, isn't it? So what this is actually showing is showing a spike complex, which composes of two parts. It has a duration and it has an intensity. And what our algorithm can do is it's an automatic way of figuring out where this spike wave is instead of having an expert to read them. Because up until now, there is actually only a handful of specialists, not only in Ireland, but throughout the world, that can read these complex waveforms. So our algorithm, we hope, is a solution to this problem. And one other area that we're looking into, that our future development is, we're looking into, it's called BabyLink. And what that involves is, we are hoping to combine the amazing sound that you heard at the start of this talk with the sound, with the neonatal algorithm. And we will be able to send that wirelessly to our smartphone technology. So, for example, if a baby is having a seizure in the unit, we will be able to send this information. The nurse will be able to ring up the doctor and say, "Would you mind having a look wherever they are in the world," and say, "Could you read this scan for me, please?" And the doctor will be able to give a solution. So that is just one of our future developments here at Infant. So just to conclude, by taking different perspectives from different backgrounds and looking at things in different and innovative ways and bringing them all together, we here at Infant have come up with a solution to a very complex brain problem. And not only do we want to share this knowledge with you and Ireland, but we feel that this knowledge should be shared throughout the whole world. Now, isn't that an idea worth sharing? Thank you.